The last two things that we covered last week were powers to a negative exponent and powers to an exponent that's a fraction. So let's look at negative exponents first. Negative exponents. So the way I want to start this is let's look at a quotient problem. We're going to look at something that's a division problem. So maybe x to the third over x to the fourth. If I wrote this out, extended it all the way out, I'd have 3 x's on top and 4 x's on the bottom. I'm going to cancel out my matches. I can see that I'm left with 1 x on the bottom and nothing left on the top. So I'm going to put a 1 up here as a placeholder to show that we still have a division problem. The numerator is 1, the denominator is x. So if we followed our rules of our quotient or our division, we could take x to the 3 minus 4, so my numerator minus denominator. This is going to be equal to x to the negative 1 power. So now I know x to the negative 1 power is also equal to this guy. These are both the same math problem we've got going on here. Here I got x, 1 over x. Here I've got x to the negative 1. So every time that there's a negative exponent, I can see that there might be a fraction. So let's take a look at another one. Let's make this number still 3. Let's make my denominator a little bit bigger. So again, I have 3 x's on top. I'm going to have 5 on the bottom now. I'm going to cross out my pairs. Now I'm left with 2 x's on the top. I'm going to put a 1 up there again as a placeholder so I can see that those x's are in the denominator. And this can be simplified as 1 over x squared. X times x is x squared. So instead of doing it long ways, let's do it with our rules of division. Take my numerator, subtract my denominator. 3 minus 5 gives me negative 2. So I know 1 over x squared is the same as x to the negative 2. X to the negative 1 is 1 over x. X to the negative 2 is 1 over x squared. So I could write this as, let's give ourselves a little chart that we saw last week. X to the negative 1, x to the negative 2, x to the negative 3, x to the negative 4, maybe x to the negative 100. Okay, so we know already x to the negative 1 was 1 over x. We know that x to the negative 2 was 1 over x squared. So following the pattern, I can see that 1 over x to the third is probably x to the negative 3. 1 over x to the fourth is x to the negative 4. And then we jumped up to x to the 100. X to the negative 100 is 1 over x to the 100th. So when I have a negative exponent, I can see that the negative exponent then turns into a fraction. In math, we don't like negative exponents. So every time you have a negative exponent, your goal is to turn it into a fraction and get rid of that negative exponent. I can see here it's negative, here it's no longer negative. So now this is our happy column, this is our sad column. Okay, now let's look at what happens if my negative exponent is on the bottom of a fraction. So maybe I have x to the third on top, x to the negative fourth on bottom. if I set this up with my rules for division, this is x to the third minus -4, my numerator, minus my denominator. If I take a minus, that's the same as a plus. So I can see that this is x to the 7th. So what do you think happens when we go from here to here? So we know that x to the -4th is the same as 1 over x to the 4th. This looks terrible. We've got a fraction with a fraction as the denominator. So I'm going to write this as a division problem. Instead of having it set up as a fraction, I'm going to write it as a division problem. If I set up my division, I want to make them both fractions so I can use my rules of dividing fractions. The rules are, as we said last week, when I have two fractions and we're dividing them, it's our keep. So I'm going to keep this. This guy I'm going to change. This guy I'm going to flip. Keep this guy the same, x to the third over 1. Change this, so instead of a division problem, we now have a multiplication problem. And then flip. So I'm going to flip this over, so now I have x to the 4th over 1. Multiplication of bases makes me add my exponents. This brings us back to x to the 7th, which is what we ended up with here. So what I can see from here, I get to this point, all that I had to do is take this negative exponent and move it up here and make it positive. So let's get rid of this for some room. If I moved this up here to make it positive, I'd have x to the third on top. And now x to the positive 4th on bottom. I'm going to keep that 1 there as a placeholder since nothing's there. This gives us x to the 7th over 1. So if I have a negative power in the denominator, I'm going to move that entire statement, so x to the 4th all comes up to the top. If I have a negative statement in the top, I know this is 1 over x to the 3rd divided by x to the 4th. Again, I'm going to set this up as a division of fractions. 1 over x to the 3rd divided by x to the 4th. I'm going to rewrite that guy as a fraction. Keep, change, flip. Keep this guy, change this from division to multiplication, flip that guy. Now I have 1 over x to the 7th, 3 and 4 is 7. So I could see, let's get rid of this. I could see what happened here is that this exponent has moved down. So this is the same as taking my negative, moving it to the bottom. So negative exponents, they're just going to flip sides of, fraction bar. If it's negative on top, it's going to go to the bottom. If it's negative on the bottom, it's going to end up on top. Okay? So again, this is a good time to pause because I'm going to erase it. Last thing is our powers that are a fraction. So maybe I'm going to have x to the 2/3. We've got a whole number base and a fraction in the power. Every time that you have a fraction in a power, you're going to end up with a square root. So fraction as a power. We're going to have some sort of radical. These ones might not always be square roots. So in this case, I'm going to take my denominator and put it outside of the radical. So this is my radical. I'm going to take my denominator, and that's going to sit right here. So this is not a square root, this is a cubed root. We're looking for what number times itself 3 times. Gives us x to the 2/3. Then we're going to take our numerator and put it inside. Radical with its base. So I'm going to take the base and the numerator here. So x to the 2/3 is the same same thing as cube root of x squared. So let's look at one that we can simplify a little bit. So if I have x to the 4 halves. I know since this is a fraction, I'm automatically going to have a radical. My denominator is going to go on the outside. So this is a square root problem. We're looking for pairs, things that happen twice inside here. And then I have x to the 4th. So my base and my numerator are inside. I can break this down into x to the 4th is x times x times x. Now I'm looking for groups of 2. Here's a group of 2. Here's a group of 2. There's nothing left, so I know that I'm no longer going to need a radical. This group comes out as 1. This group comes out as 1. So I'm left with x squared. The square root of x to the 4th is x squared. I could also take a look at this here. When you had x to the 4/2, 4/2 simplifies to x squared. In this case, this might have been the easier option, but they're not always going to work out like that. So you're going to take your denominator, put it outside, your numerator, put it inside. Let's look at one that's not a square root since we've practiced square roots before. Let's look at one that's maybe a cube root. So let's do x to the 7/5. We can see 7/5 doesn't simplify. 7 divided by 5 isn't a whole number, so it's not going to work out as nicely as the last one. I know I'm going to have a radical because this is a fraction. I know my denominator sits out here, and my numerator is going to go with my base inside the radical. So now what this is saying is we're looking for groups of 5. So there's 7 x's in here. 1, 2, 3, 4, 5, 6, 7. All right. And I'm looking for groups of 5. So here's a group of 5. And then I've got 2 x's left over. So those 2 x's have to stay behind. And then this group of 5 is going to come out as 1x. We're saying 1 group of 5 x's, and then there's 2 left over, guys. So this simplifies to x, and then the 5th root of x squared. Okay? So that's all of last week, all recapped. I'm going to give you guys a link for a Google form to fill out to practice this stuff. And then we're going to move on just a little bit. Chapter 10's not super long, so we will have a test coming up. But I'm going to give you guys plenty of time to practice these things. And also, please just make sure that you give me as much feedback as you can on how this is going. I'm definitely willing to make changes, make things as easy for you guys as possible while we're still kind of going through this online learning thing. Okay, so keep it up.